Welcome back to Interstate and Main Street, where we connect Interstate Engineering's expertise to the communities we serve. Today we're talking about a new UAS platform to Interstate Engineering's fleet that utilizes enterprise-grade drone LiDAR and why this changes how engineering decisions are made. I'm Michael Hardy, a senior graphic designer here at Interstate Engineering. I work with some drones from the marketing side of things, but I'm starting to learn that this new technology goes way beyond just photos and videos. With me today is Ryan Scanlan.
I'm Ryan Scanlan. I'm the point cloud data manager at Interstate Engineering. I have a degree in civil engineering and a background in construction, but found a passion for drones in my time at Interstate, which has led to some very exciting things.
Yeah. So today we're going to talk about the difference between consumer drone mapping and enterprise-grade LiDAR that we currently have here at Interstate Engineering. What did we currently have, and what are some of the future drone capabilities that we're implementing now?
So it started out with just general pre-con, post-con progress pictures and stuff, and using off-the-shelf drones to do what we needed to do. And then it slowly turned into, well, hey, we can go measure that stockpile because I didn't want to crawl up the stockpile, and just morphed into a larger and larger thing until we officially started the point cloud department in, I believe it was 2021 or 2022. But in 2021, we invested in a DJI M300 with a P1 camera. That was a huge step up. We had one of the first ones on this side of the Mississippi, actually. And that we started doing bigger and bigger projects. And then it's kind of turned into where we have a good number of drones and good number of pilots in each region across the company. And then we used the M300 for a really long time. 2 or 3 years ago, we invested in LiDAR, which is light detection and ranging technology, helps with vegetation penetration and such. And that was, we invested in a YellowScan Mapper Plus, so that was a big jump up for us. And then recently this year, we invested in a YellowScan Voyager, which is top of the line stuff.
These drone platforms, not everyone can fly these. What kind of certifications or qualifications do you need?
For sure. So federal government requires an FAA Part 107 license to do anything with commercial purposes. So all of our pilots are their Part 107, of course. And then we do some internal training and stuff to make sure we're following regulations, making sure we're compliant.
Nice. Well, we can go ahead and start talking about the new platform that we have, the Skyfront P8 and the YellowScan Voyager. You just want to talk a little bit about that?
Yeah. So both the Skyfront P8 and the YellowScan Voyager are both very, very interesting advancements in the technology. The easy one is the Voyager. It's a very large LiDAR sensor, and it is top of the line. It gets up to, I believe it does 2.1 million points per second at most, and it gets up to 32 echoes if I'm getting my numbers right there. And so what that translates to is just a lot of data on the ground. It's really incredible. We've done some projects with it that it's just every time I see the data, it just boggles my mind. And what the echoes translate to is just essentially vegetation penetration. So the YellowScan Mapper, it can get up to 3 echoes. And then, so the Voyager can get up to 32 echoes depending on some settings and stuff. So what that translates to is even in some really complex, really vegetated environments, we're still able to get to true ground. And then the Skyfront P8 is also a really interesting platform, as it's actually it's not a true hybrid, but it actually has a little 2-stroke motor on it. So it is using both gasoline power and battery power as a backup. And what that enables is extreme endurance. Even with the Voyager is about 8 pounds. So even with that large and heavy payload, we're able to fly for about 40 minutes to an hour, which with the Voyager, we're able to fly higher and faster. So what this translates to is being able to capture huge amounts of area in minimal amounts of time.
Yeah, and like the you don't have to stop and recharge batteries. So you just bring in a couple gallons of fuel and you can just keep going all day. There's no downtime. You can
100%.
fly a lot.
Yeah. It's the battery management equation has been a huge part of the limiting factor of how much area we're able to cover. With the M300 and the mapper, I would say at most we were probably able to cover about 1,000 acres a day, maybe 1,200 if conditions were right. Now we can cover that in just a couple of hours with the Voyager and the P8. So huge deal. And then the other thing that's cool too is our mapper, we didn't have a camera with it. So we would have to fly it once for LiDAR and then once for an orthophoto. And now with the Voyager, we're able to cover it all at once. So which is really cool.
Yeah, I thought that was really cool. You talked earlier about the YellowScan Voyager and how you can see through vegetation. I know you showed me earlier a cross section of a cornfield, and you can actually see through the corn and see the ground, and even like a valley where you can see the trees, and you can actually turn the trees off if you don't want to look at the trees, and then you can see the ground. So that was really cool.
Yep.
So some of the specs on the Skyfront P8 is that it is Starlink compatible or has a Starlink on it. And
so it actually flies over Starlink. That's one of the really cool things because it is a very heavy lift platform. So it actually has a Starlink panel on it, and we have a Starlink panel at the base station, and it's flying over Starlink with a radio as a backup, which is really cool and enables a lot of interesting operations. And just the reliability is huge too, just for not having to worry about your connection per se.
Mm-hmm. Yeah. All right. So this is a pretty impressive platform and system that we have here. How did we go about getting this and acquiring it? I know we worked with Frontier Precision, and I think the relationship you have with them really helped out procuring this.
Yeah. So we work with Frontier Precision and the unmanned side of Frontier a lot. So we use them for all of our geospatial stuff, as well as now that we have a full-fledged drone program, we use them for all of our drones. And they were huge in helping us acquire this, both from getting us some example data. We did some trial projects and such with them. The amount of times I had Colin go and be like, "Hey, can you just like fly this so I can show what somebody what it would look like?" Was huge. So I've been working on getting a Voyager for about 3 years, and now it's finally paid off. And they definitely played a huge part in that and getting us to that point.
So do you want to go into detail about the difference between the YellowScan Mapper and the YellowScan Voyager, and the difference between, I guess, consumer grade and enterprise grade LiDAR? Yeah.
So there's not really a huge kind of to understand drone mapping. There's a little bit kind of levels to it. So I would say, in my opinion, at kind of the bottom level, there's photogrammetry, which is kind of basic. You can do it with any consumer grade drone off the shelf. I actually, when I was in college, I would go and do help some people out with like stockpiles and stuff with just like an off the shelf, bought it at Costco. I think it was a Mavic Air, like ancient nowadays, but super easy to do. It's all it is just overlapping photos using trigonometry and saying, "Yep, I can see this rock in multiple pictures. I know where that picture is at geospatially. We can draw two triangles," and that's what photogrammetry basically boils down to. And photogrammetry is what we call a passive sensor, because it's just taking photos and it can only map what it can see, and works obviously for the ortho photos, which we use a lot of. It's incredible because we can see where things are at 2D on the map, and they're spatially accurate. So kind of the next step up would be, say, the Mapper Plus, which would be like kind of an entry grade LiDAR sensor. So we would pair that up with our M300 drone, and that kind of took us on that jump from photogrammetry to LiDAR. And the huge thing with LiDAR is vegetation penetration. There's some people think one replaces the other. It's not necessarily true. There are areas where photogrammetry excels over LiDAR and vice versa. But the big thing is with LiDAR, we're getting the vegetation penetration, which is a huge part of our business. County roads, vegetated areas, etc. We very rarely get to work in really nice, smooth, flat, nothing's there areas. So the Mapper Plus was kind of our first venture into that. We did a lot of work with it, did a lot of it, covered a lot of area, and it was a great sensor. It still is. We still use it for its niche cases and stuff. The biggest thing is it just didn't quite have the power that we needed for vegetation penetration and stuff, just in how complex of terrains we work in. Mm-hmm. So kind of the next step up was there's some intermediate steps, but we decided to make the investment into the Voyager. And the Voyager, again, that's where we start getting into that 32 echoes up to 2.1 million points per second. It's just a massive step up and just top of the line system. And so when we get into projects in, the Black Hills or the Beartooth in Montana, or even just county roads in North Dakota, that vegetation penetration is so huge because it helps us limit the amount of on the ground surveying we need. And that's huge. Obviously, it's a huge time saver for us, which is a huge money saver for us. But also there's a huge safety factor involved where, because we're using these aerial surveying platforms, we don't need to have people down on the ground in traffic doing that sort of thing just to get a centerline shot of the road or something like that. We're able to capture it from the drone. A really good example of that is when we had the flooding in Red Lodge in 2022. We wouldn't have been able to get out and get those bridges surveyed without the aerial mapping for a month or two after the event happened. But because we had the aerial surveying capabilities, we were able to be on site getting those surveys done same day, and we were essentially able to start designing those bridges and getting them procured within the week or so. So
yeah, it sounds like that it can collect a lot of data in a short amount of time. But I guess this isn't to be looked at as a shortcut.
No,
correct?
No, not at all. Not at all. I think that's a really common misconception is a lot of people hear drone survey and they think that's all there is to it. We go and fly with the drone and we're done. Not at all. That's not how we treat drone surveys. It's definitely a tool in the toolbox for us, not a replacement. So obviously with these more advanced sensors and such, even in the photogrammetry world, going from like a Mavic 3 to like the P1 camera, you're getting better data, you're getting more accurate data, and but it's still not going to replace somebody being on site collecting the data right there in front of it. It's the same as like a GPS on a virtual reference station network versus a total station. You're going to get better accuracies, and there's just certain things that the drones aren't able to see from the air, which is fine. But a lot of people are definitely treating the UAS systems as just total replaces, fly it once, build the road, call it a day. That is not how we treat it. It's a tool in the toolbox, and it's a massive force multiplying tool, but it's just another tool in the toolbox. Yeah. We still need to verify. We still need to shoot ground control. Still need to shoot check shots, and because we're in the business where accuracy matters.
Yeah, right, for sure. And how does this data, after we collect it, how is it used in the future? I know we use it now, but we can kind of archive it.
100%. It's definitely a thing, especially with this new Voyager. We're able to collect a lot of data and a lot of like really accurate data, and it's almost like having Google Earth. Like if you go back and look backwards in Google Earth, you might be able to tell there's a building there, with data from 50 years ago or whatever. But nowadays it's gotten super high resolution and such. And it's kind of the same concept where if we're collecting with the most accurate system we have at our disposal, that goes onto our servers, we archive it, etc. And 10 years from now, we never know how that project might expand. Or the other way to look at it too is especially with this new Skyfront and Voyager combination, we're able to collect so much data in such a wide area very quickly and effectively, that now if we have multiple projects kind of in one area, we can save the client, all those clients, a large amount of money just because we only have one mobilization versus before we might have had 2 or 3 mobilizations because of the area needed to cover, or might have had to treat each site as its own project. But now we can kind of collect it all as one aerial mission, so they're kind of splitting the costs. So that's a huge part of it. And then, like you said, just kind of like from an archival perspective, as we do like large area flights, we have quite a few clients where we are flying it, once a month, once a week, etc. And they're using this data as, instead of having a team of surveyors out there that's out there constantly collecting data as dirt moves, the material changes, etc. We're just out there, we fly it, we're done. They have the data within the next week, and they're off to the races, and things are just going smoother. And a big part of that is we're just able to collect so much more dense data. The comparison that I always make is, it used to be we'd go out and shoot like a 20-foot spot grid or a 10-foot spot grid, etc. Versus photogrammetry and LiDAR are both very similar in this regard, where we're getting at least 30 to 60 points per cubic foot is kind of the measurement that we use. And it varies, of course, depending on conditions and everything. But once we start dealing with that, we're getting very much digital twin recreations, which is massive for quantities and design in general.
You talked about how the Voyager 20 collects so much data and in the end can benefit the client, save money. What other kind of benefits does this platform have?
For sure. So we're just able to collect such a large area of land, and what that translates to is we can minimize mobilizations. We can spend more time on more detailed areas. So, if you have a 40-acre site, we can fly the entire 40 acres instead of just focusing on small areas of it with, like a conventional topo would do. And then the other thing is just the density of the data. We're able to collect such dense data that things such as like grade checks and that sort of thing, they're going to connect so much better. And then that's also being combined with just the vegetation penetration of the Voyager, where we're just going to get so much closer to ground compared to, say, photogrammetry or something. Mm-hmm. And it's such a minuscule thing, or such a small thing in theory, but it turns into such a huge thing, especially once you start getting onto these 200, 300 acre mass excavation projects where we need to be able to tie the data in. And it's very much where, in my contractor background, the surfaces, might not have fit perfectly, and we would just field fit that in essentially. And now we're just getting to the point where things are just, because of the tech power of the computers and everything, and the software is advancing so much, we're able to very accurately model what is going to be built in real time. And because that modeling software is there, we need to be able to model the real life conditions as well. We refer to that as a digital twin. But it's also opening up doors to where we're taking some adventures into like virtual reality viewing and augmented reality viewing, enabling the clients to see what their project's going to look like before it ever gets built, which is a huge, awesome deal. We're also working with some architects as far as modeling real world conditions on their plans, as well as inside and outside. We have our terrestrial scanners and such. The benefits are endless. If it's it's kind of hard to put a vague blanket statement on it.
Yeah.
Because it is something that just I could find a reason for use LiDAR on any project, because it is such a huge benefit. It's super nice to have the data, and the amount of times where a project changes, and because we are in the rural part of the world, it minimizes us having to go back and recollect data, because we have that digital twin data that is highly accurate. We can say, if a water line needs to move for some reason, or there's something like that, we can go and essentially perform a quote unquote office survey and collect that data and not collect the data isn't the right word, but we already have the data. We can translate that into usable deliverables.
Yeah. And then another benefit that might help our clients too is this platform is NDAA compliant. Even if it's not a federally funded project right now, that can benefit in the future. Can you kind of go over what the NDAA compliance means and how it benefits the customers?
100%. Currently the NDAA is a massive thing affecting the drone industry. So the NDAA is the National Defense Authorization Act, and anything with federal funding is going to require an American-made drone and sensor package, etc. There's some semantics involved, but what it does is really complicates the space, is the word I'm going to choose to use when it comes to federal funding. And the nice thing with the Skyfront and the Voyager is it is fully NDAA compliant. So we are able to use it on federally funded projects. And the big question I get asked a lot is, well, if I'm not using federal funds for the drone survey, can I use it on, use that drone survey data on my federally funded side of the project? No. Pretty much as soon as that data gets used on anything that involves federal funding, it has to be done with an NDAA compliant drone. Yeah, it really complicates the space. It really raises a lot of questions. There's a lot of things up in the air right now, but not pun not intended. But we are taking kind of the stance of we are going fully NDAA compliant. So just one less thing we need to worry about. So, yeah.
Mm-hmm. Yeah. It seems like the government's always coming out with new rules and regulations, the FAA and all kinds of certifications and qualifications you need to be able to fly these platforms, which I think is a good thing because you don't want anybody out there flying a drone.
Oh, yeah. It's getting to be a very complicated space. There's the FAA, they've in my opinion, they've taken a really They've handled this very well with remote ID and everything, where, I mean, they are trying to open up the door for beyond visual line of sight operations. So
yeah, the FAA made it mandatory for drones that are flying to have remote ID. That's, consumer grade and enterprise grade. But what do people think when they hear drone?
It's a wide concept because, I mean, you have everything from your little drone you buy at the gas station that costs you $5 and you crash it 5 minutes later to stuff like this Skyfront P8 with the Voyager. And it's a really hot button topic, drones in general, because people don't like drones flying over their houses or, et cetera. The big thing is, and the term I use a lot and make sure that we're using in our proposals and stuff is we try to stay away from the word drone. We use UAS because UAS stands for unmanned aerial system, and it is a system. It is the drone and the sensor, and it's everything involved with making that drone fly. So I like to use the word UAS. I kind of use them interchangeably, but as far as when it relates to us and using them at work, I like using the word UAS because it is a system. Most of our drones, we are able to change the payloads. We can put on cameras, we can put on LiDAR sensors, we can use thermal cameras, we can do all sorts of things. And it's a huge space. And it's in my opinion, I mean, I'm the drone guy at Interstate, so I have a pretty strong opinion at it, but it is the future and it is such a huge thing. And I kind of mentioned it earlier where the FAA is trying to work towards BVLOS, which is beyond visual line of sight operations. And it's going to be such a huge thing to kind of help with that narrative. And just because there's a drone flying over your house doesn't mean it's spying on you. And the big thing is, the FAA treats these drones as aircraft. I mean, they are the same as like a Cessna flying over your house. We can only fly up to 400 feet without waivers. But, just because it's flying over your house does not mean we're spying on you or anything. We're trying to collect data to help better your neighborhood, your city, etc. And this is a huge force multiplier for us. We are able to lower our costs to help do more projects and do bigger projects because of these systems. So that's my soapbox for the day of like, please don't shoot at my drones. Cause it's something I get threatened with a lot, but, overall the perception is really good, I think, but you get a few cases here and there, but yeah, that's definitely what I think when people hear the word drone, they think the neighbor kid down the block is flying it around in a circle and doing its thing, where we are doing large pre-planned, authorized missions, and we're doing our due diligence. We're checking our airspaces and we're making sure we're following the regulations and doing what we need to be doing. So, if you ever have any questions about a drone, just follow it back to home. It's got to come get gas or get a new battery at some point. Yeah. And I'm sure the pilot's more than happy to talk to you about it.
Yeah. No. But yeah, bringing it back to the platform being a tool and kind of leading up to a mission, doing the QA. When does that start, and like what does that look like for you?
Yeah, so QA is a huge part of this. It because it is such a new system, we definitely got to prove it. So QA is a huge part of it, and me and Michael were talking about this a little earlier, and I'm going to use his words here, where QA starts before we even take off. The mission planning, everything from start to finish to the data upload and download and processing, is a huge part of all this. It's very important. We are still creating data that needs to be stamped by a licensed professional, and we are providing them with that data and saying, yes, this is accurate. So we have QA procedures. We're making sure we're shooting ground control, we're shooting checkpoints. There are standards out there as far as like the ASPRS and stuff. But it's a huge thing, and you need to make sure you're effectively mission planning to make sure you're covering areas that you need, while also staying out of areas that you're not allowed to fly over. And you're also checking airspace. You're also doing all sorts of things. And we've very much gotten to a point where the procedure seems pretty straightforward and autonomous. But I constantly have to remind the new pilots of like, hey guys, let's go back to the basics here. Like, yes, this seems very autonomous, but you need to understand what's going on in the background, because there's a lot. It's all very important. It's all when the thing with the drones is when it goes good, it's awesome, and I would say it goes good most of the time. But every once in a while, you get a flight that goes bad, and things go downhill very quickly. And when you're capturing the amount of area that we're capturing, and we're able to deliver the data at the speed we're able to deliver it at, when things go wrong, they go wrong very quickly, and you have to be able to recover and pivot and get back out there and redo it. Yeah.
And I think part of the QA, starting early, like you said, accuracy, but a huge thing is safety too.
Yeah.
We definitely want to be safe, fly safe, be compliant with all the regulations and airspace.
100%. And it's a part I miss constantly, because it sounds wrong saying it's in the back of my head, but it's always there, where I kind of touched on it earlier, where we're also keeping our crews safe. So obviously airspaces and such are a huge thing, getting our lands clearance and stuff, but we're also able to keep people out of unsafe areas, and just keeping them. Our pilots love it because they get to just hang out and don't have to go stomping through the marsh and doing all sorts of stuff. But we're also keeping them in an area that we know is safe, it's secure, and we don't have to send them out, even things as little as, maybe there's a snake or a bumblebee or something. But safety is such a huge part of the UAS industry, and it's really important.
Safety is a big priority for us. And I know that was one of the challenges that this new platform helped solve for us, and all of our UAS platforms. But what other challenges has this system solved for us?
Yeah. So with the new system in particular, the biggest thing is the vegetation penetration. Is, like I said earlier, going from the Mapper Plus, which had 3 echoes, to 3 echoes, and I don't have the numbers off the top of my head, but I want to say it was like 300,000 points per second. It was in that like 300,000 to 500,000 points per second, I think, to this Voyager, which is up to 32 echoes, 2.1 million points per second. Just the data density and the vegetation penetration is a huge thing, and it opens a lot of doors up for us as far as new features that are being actively developed. The nice thing with the investment that Interstate has made into the technology and everything is we're keeping our softwares up to date. We're keeping our sensors up to date and everything, where we are able to do things like curb and gutter auto extraction and tree counts. And the point cloud space in general, here, I'm going to go on my mantra here, is such an interesting space. And in my opinion, it is very much the future. I talked about digital twins and stuff, where the world is moving to model-based design. The plans and specs are really nice to have that nice piece of paper, but we are moving into a 3D world. And we, even just in my time at Interstate, we've gone from kind of like a 2D based design approach to a 3D design based approach, where we're viewing these models in 3D as we're designing them and stuff, and having a hyper accurate model of the world to design that stuff off of is such a huge part of it. And so as far as like a challenge that it helped resolve is just that real world modeling, where, before it was, well, we need to go shoot some ground verification break lines to make sure we're actually hitting the ground at these elevation critical areas. Versus, again, like I said earlier, we're not going to replace the guy on the ground by any means, but it's a supplement where we can spend more time in more critical areas because we have so much higher confidence that we are hitting ground. And there's a lot of really, going back to the extraction part of it, there's a lot of really, really cool advancements as far as like lane line extraction and the tree count. If I could find a project to do that, somebody says, I want to know how many trees and how tall they are on my property, I'd be so excited because it's a button I've pressed so many times and people are like, cool, I just need to know where the tree was. I don't care about how tall it is or how wide the trunk is. I'm like, yeah, but it's so cool.
But you can.
But I can. It's possible to do. And with this sensor, and it's another really cool thing we can do with it is because of, I didn't really touch on it, but the intensity mapping is such a huge part of it, because as that beam of light, it comes down and hits the ground, it returns at a certain intensity to the sensor. And they're doing a lot of really cool things, both on the classification side of things to help us say this is a tree, this is a building, etc. But also they're using that as tools, because if it hits pavement versus metal, it's going to return the light differently. And they're doing really cool things like where we can automatically detect manholes, where the trees, curb and gutter, power lines are a huge one, where it will automatically extract those power lines. So instead of going out with a total station or something and measuring the points on the catenary curve, now we're getting a full line of where that is, and we can measure it directly. So, just that challenge is just, I would guess it wouldn't so much be a challenge as much of a new frontier, where it is, we are on the bleeding edge of it. I get to meet with some really cool people, and sometimes I meet with them. They're like, you want to do what? Like, I guess it's possible. That's okay. And it's really cool to be on that bleeding edge of technology. And it not only helps us, I mean, if you can't tell, I'm kind of a nerd about all this stuff, but it's also helping out our clients and helping us work more efficiently, and get our stuff done and get them a more accurate result.
Yeah, that's actually some really impressive things you can do with the LiDAR. I didn't realize you could do a tree count and the power lines and
it's cool. It's fun to watch. It's fun to let the program do its thing.
Yeah, I suppose there's a lot that it can do that people might not know. So what are some misconceptions about LiDAR that
for
people
sure
don't know?
The biggest misconception is, in my opinion, is people use LiDAR as just like a generic term. But like I said earlier, there's photogrammetry, then there's LiDAR. Those are two very distinct things. I kind of touched on it a little bit, where photogrammetry is a passive sensor. It's just taking pictures. LiDAR is an active sensor. I think I forgot to talk about that a little earlier, where it is actually shooting out beams of light. It's shooting out those 2.1 million points per second and waiting for them to return. And that's a huge thing where photogrammetry, we can only map during the daytime. Here in North Dakota, the wind likes to blow during the daytime. And so we actually had a project a few years ago where we had like 3 weeks. The project needed to get done. The wind was howling like crazy during the day, whatever. And we would go out at night and do our mapping during the night because the LiDAR is, it's creating its own light. So we're actually able to map at night, do its thing. And it's actually really impressive. I ended up doing a landfill at night a few years ago. It was the first one I did at night, and it baffled me when I brought the data in because I'm on my side of things, on the data side of things, it's in black and white, but it looks like it's daytime essentially, where you can see and tell like, oh, this is a washing machine, this is a tire, this is it's really impressive and it's really cool. But I think that's the biggest misconception is there is a difference, especially like talking to our clients and stuff, where it's, the LiDAR does cost a little more. It is a little more of a investment, but taking the time and talking to them and saying like, hey, person A is offering photogrammetry. You're only going to get the tops of the grass and the tops of the trees and stuff versus LiDAR. We're actually going to be getting to the ground and giving you a much better end result because of it.
Yeah, definitely more accurate. What are some questions that clients, don't ask you that you wish they would?
I wish they would ask to see the data more often. Because it is such a new technology. It's I've been full time at Interstate for 6 years, and even in that 6 years, even in the last 2 years, there have been such huge advancements as far as being able to view the data. A lot of times, our clients are just getting a blueprint essentially. And they don't get to actually see the data, and they don't get to have the wow factor of, oh, that's what they collected. And I wish more often clients were like, hey, I actually want to see the raw data or the data from the point cloud, and a lot of times they just aren't aware that exists because they don't know the verbiage and stuff. But for example, I did one a week or two ago where with the LiDAR, we're actually able to process it and check it while we're out in the field. And we were checking it, and a client was standing right there. I'm like, hey, why don't you come and take a look at this? And he went, wow, I had no idea that's what you guys were doing. Like I thought it was just going to be like 1 point every 20 feet or something. I'm like, no, it's really
very detailed.
You can see us standing right there, and you can see that we're wearing safety vests and stuff. And he was like, wow, this is amazing. And kind of one of my funny stories from that is my sister used to work at a mine, and the guys hated when the slam lighters would come through because they would be like, oh, that guy had his safety glasses in his pocket or something. And it's really impressive data, and they've come a really long way with being able to view that data online or like on your phone or something. Mm-hmm. But it's cool, and I wish clients would say, I want to look at that data, and also just how do I use that data? Because I love spending some time with the clients and being like, okay, if let's spend some time and figure out, I want to give you the full data set and you use it to your fullest advantage, because in the last couple of years, they've made a lot of really cool advancements as far as being able to view that data online, but also put it into a platform where you're able to say like, oh, I want to know how big my roof is, or, take measurements essentially and put that data into an online platform where you as the client would have that tool to take measurements as you need it and stuff, instead of having to call us up and say, hey, Ryan, like I need to know how big this square sidewalk is or something. There's also a lot of really cool tools out there as far as like, I'll make a plug for like Triceps here, which is Trimble Reality Cloud platform service, where with the right setup and the right project and stuff, we could actually bring all that data in and put it into a platform, which essentially gives a real-time link between me in the office, the guy in the field, and the client, where if we're uploading our scan data and stuff as we go, they see something they want to comment on, instead of having to go out into the field, they could just put a note on there that says, hey, like, can somebody take a look at this? So just enabling kind of that remote environment where the world moves very fast nowadays, and we're all very busy, and just giving us the ability to be on multiple sites at once and to put a loose term on it is huge.
Yeah, it's definitely advanced over the last few years, and with the data and data collection and even storage is a whole nother issue because of the amount of data that's collected.
100%.
It's huge.
Yeah.
The amount of data that needs to be.
It's I can't remember the exact law, the name of the law or whatever, but the technology moves at an exponential rate, and you can definitely feel it in the drone world. And even in the 6 years I've been doing it, it seems like a long time now, but it's not very long.
A lot has changed.
Lots changing really fast. I actually saw my survey professor at a career fair a few months ago, and we were talking. And I remember when I was in college, the Phantom 4 RTK was like the latest, greatest, coolest thing ever. And now it's like that thing seems ancient technology now. And it's insane, and I'm excited to see where it's going. The hybrid drone space is blowing up like crazy. The fixed wings and such. There's some really cool technology in that term. And then as far as big thing we talked about today was just the Skyfront being able to the long endurance flights and stuff. Mm-hmm. And the more time we can spend in the air, the more data we can collect. And we're getting to when I first started doing this, 20 minutes was a really long drone flight. And now if I'm not getting like 40 minutes an hour out of a drone, I'm like, man, is that something I really want in my arsenal?
Yeah.
And that technology is just continuously improving, and it's impressive to say the least.
Yeah. Like we said earlier, just the drones are changing so drastically, so fast. I'm just curious to see what the future is going to look like for the drone space, or the UAS space, as we would put it, especially for the enterprise grade LiDAR and drone platform that we have. We talked about a lot, but did you want to sum everything up we talked about real quick?
For sure. Yeah. So essentially, we have created a full one-stop shop for surveying in general, but we utilize UAS really heavily, and whenever we can, and we are able to provide whatever you need, and we are all about tailoring a solution that fits your needs and your budget. The idea is, some people, they might just need some photogrammetry just to figure out some general things. And, we're not in the business of overselling. I would love to use a Voyager on your project if you want the Voyager on your project. But if you just need photogrammetry, then I'm not going to oversell you. And there's a wide variety of solutions to fit a wide variety of needs is kind of the summary of it. And we are able to provide all those things. We have quite the arsenal at our disposal. And it's just really important to pick the right tool for the right job as with anything. And with this investment in the Voyager, we're not scared of large projects. We weren't scared before. There's some times where people thought I was a little crazy on certain projects, but this Voyager opens up a whole lot of doors as far as getting into some complex terrain, getting into complex vegetation states, and that sort of thing. And it just opens up a lot of doors as far as data density and accuracy. As far as we try to stay on the bleeding edge and providing data that we can trust and verify, and not provide any worry as far as both on our side of things and the client side of things, of just being able to trust the data and move forward with the data and create actionable data sets where we can see, it's getting to the point where it used to be like, when I first started, it was, there's a road there. It's this elevation, but we're getting to the point now where, we can see rutting in the road. We can see different things like that. And I'm not going to go on to a whole side tangent about mobile mapping and stuff where we can measure cracks in the road and stuff. But it's a lot of really cool technology being put in place. And I think the big summary is it's a force multiplier. And we're able to, projects are getting bigger and badder. People want more, want their dollar to stretch farther, which is totally fine. And we're creating a solution that's able to do that.
Yeah, that's awesome. I learned a lot today, and I'm excited to see where this platform takes us.
Yeah.
Well, thank you for being on the show.
Of course.
If you're curious on how enterprise grade LiDAR could help your next project, just reach out to the Interstate Engineering team for more information. The links are below in the description. Thank you for listening to Interstate Main Street. Until next time.